Here's a crude sketch of a carbon pile voltage regulator generator system on a World War II airplane. The three main components of the charging system are, of course, the battery, which is 24 volts, the generator itself. Our goal with the generator is to produce 27.7 volts. It's necessary to have more voltage in the generator than the battery because you have to kind of push voltage into a battery. If the two were equal, if they both equal 24 volts, there wouldn't be any current flow from the generator to the battery. So you have to increase the voltage a little bit on a charging system to force the voltage into the battery. The next part of it is the voltage regulator itself. If you take a generator and you increase the RPMs of the engine, the generator spins faster, the output voltage increases pretty significantly. If you went from idle in an airplane to full power, you would have a huge increase in voltage coming out, sometimes to a point where it could actually cause damage to the battery or avionics or some other electrical component in the plane. So that's all regulated by using the voltage regulator. So we're showing here a bus on the right hand side that's positive. All the positive connections are made to that bus. And we also have the ground, which is all negative. And the generator feeds the battery through the brushes of the armature. So the armature is turning inside of the generator, and the outer housing of the generator has a field coil. When you increase voltage to the field coil, you increase magnetism, a magnetic field. The armature then converts that into voltage and pushes it back to the battery. If you increase or decrease the field coil, you're directly increasing or decreasing the output voltage of the generator. And that's where the voltage regulator comes in. So everything in this box right here depicts the inside components of a carbon pile voltage regulator. So the heart and soul of it is carbon discs. There's about 40 or 50 of these in a stack. They're about the size of a dime. They have a hole in the center, and they look a little bit like a lifesaver, a candy lifesaver. So we're taking voltage from the battery and we're putting it in the very last carbon disc in the stack. And on the other end, we're taking the voltage that's coming through the stack and coming down as an input to the generator field coil. By increasing pressure on the stack or decreasing pressure on the stack, we will make that a better conductor or a worse conductor, and that's how the carbon pile regulator changes the voltage to the field coil, which in turn changes voltage to the generator, the output of the generator. So there's a spring with an adjusting screw over on one side of the stack. So you turn the screw in, you put spring pressure against the stack, and by default that spring tension stays there forever. It doesn't change. So the output, the default output of the voltage regulator is always a full output. So the way we vary the output of the regulator is this plunger right here. So the carbon stack and the spring pressure are pushed up against this plunger, and the plunger is operated by a coil, an electric coil. It's hooked directly to the battery. So it in effect is monitoring the battery voltage all the time. If the battery voltage goes up, the magnetic coil becomes stronger and it pulls the plunger back. which relaxes the spring tension on the carbon discs. When we relax spring tension on the carbon discs, we reduce the voltage going through them, we reduce the voltage going to the field coil in the generator, and we reduce the voltage coming out of the generator. The opposite's true. If we have a reduction in voltage at the battery and we want to increase it, the pullback coil becomes less strong. It's a lower magnetic field, and the spring becomes the dominant factor, and it makes more voltage come through the stack, which increases the voltage going to the field coil, which in turn increases the output of the generator to the battery. So this is not a on-off sort of thing where it's snapping on and off. It's a subtle linear change all the time. There's no clicking or anything going on. It's just a very smooth operation, and it's a constant change. Every time you turn a landing light on or operate some electrical function inside the plane, you're changing the voltage at the battery, and the voltage regulator is seeing that and compensating for it.